So what we're going to do today is we are going to introduce a very special topic, one that's kind of near and dear to my lineage as a psychologist, ecological psychology. And it's a massively influential idea that for some reason does not get a lot of coverage in textbooks. So I just want to make sure that your overview of perception is complete. No overview of perception would be complete without a look at ecological psychology. However, we are not done with signal detection. So that's what we're going to do first. We're going to wrap up signal detection, and then we'll introduce ecological psychology and see how far we get on that one. All right, so the outline, we'll do signal detection. We'll take a look at the CogLab on signal detection. And then very importantly, we're going to see how signal detection can be applied to something very important in today's society. All right, so just a quick recap on signal detection. The principle or the ideas behind signal detection. In your mind, you have to decide based on evidence in your mind. So based on activity in your mind, you have to decide when a signal is present and when a signal is absent. So here we have increasing amounts of evidence. Here we have the frequency with which any of those amounts of evidence occurs in your mind. And then you'll recall that we have the noise distribution, which is what is going on in your mind when there is no signal. So that is just noise. That is just the random firings of neurons, for example. That's just what's going on in your mind. And then when a signal is actually present, when there's a signal in the external environment, that signal, the evidence from that signal, gets added to the noise distribution. So each of these points moves to a new location, and that defines the signal plus noise distribution. And what we do when we decide, did I hear something or was it nothing? Did I see that or am my eyes just playing tricks on me? What we do is we decide on a certain amount of evidence, and anything above that evidence, we're going to interpret as, yes, there's something out there. Anything below that evidence, we're going to say, no, there was nothing out there. So that's our criterion level. And then we can, as psychologists, measure the distance between the two peaks. And that is a measure of sensitivity, how sensitive you are to that signal. Can you detect that signal? So some of the other terms that we introduced last time, in your noise distribution, when there is nothing there, when the evidence falls below your criterion, you will correctly say there's nothing there, and that's called a correct rejection. So remember, anything below criterion in your mind, you think nothing is out there. So that's an example of a correct rejection, but occasionally your mind is so active that the evidence will go beyond that criterion, and you will say, yeah, I heard something, or I saw something, and that is called a false alarm. On the other hand, sometimes the signal is actually there, and then you have your signal plus noise distribution. In this case, if the signal plus the noise distribution pushes the evidence above criterion, then you're going to say, oh, I've detected something, and that's going to be a hit. You're going to correctly say something is there. But occasionally, the evidence that is given is not going to be enough. The signal plus noise will not be enough to pass that criterion. In that case, you're going to miss it, and that is called a miss. So that's when the sound or the external stimulus actually occurred, but you were unable to detect it. So when we analyze, and we'll see this in the CogLab, when we analyze these hits and misses, when we analyze these false alarms and correct rejections, we can determine the distance between these two peaks. And if you have a lot of misses and a lot of false alarms, that will cause your sensitivity to be very low. However, if those false alarms and misses decrease, that'll indicate that your sensitivity is higher, you're better at detecting this signal. And the power of signal detection comes from the fact that this is a criterion-independent way of measuring sensitivity. So it doesn't matter what your strategy is in a particular scenario. It doesn't matter whether you're a risk taker or whether you're conservative. It doesn't matter if you are going to guess, yes, I hear it all the time, or if you're going to err on the side of, no, I didn't detect anything. It doesn't matter where your criterion is. The hits and misses, false alarms, and correct rejections will always give you the same sensitivity. So that was a very important development because it meant that this is bias-free and you can actually get to what's going on in a person's mind. All right, so any questions on that brief recap of what we did last week? All right, so on to the new stuff. So we actually put you in a signal detection situation for CogLab number 4. So randomly displayed dots were put on your screen, and this is known as the star field. And the target was 10 dots that were in a row. So the star field you can think of as the noise distribution. The 10 dots in a row, that's your signal. So that was a straight line that slanted downwards from left to right. And your task was just to determine, was there a target in the star field or was there not a target? And sometimes it was present and the target was there. Sometimes it was absent and the target is not there. And that was your challenge to determine, is it there or is it not there? So the variable was the number of distractors in the star field. So there was 144 in one of the conditions. So not a lot of noise in the system, not a lot of star field noise messing up your signal detection abilities. We also had 400 stars in the star field, increasing the amount of noise, and then we had 1,000 stars in the star field, massively increasing the amount of noise. All right, so in the 144 star field, once again, you have your fixation, and you would see something like that. And again, the question is, do you see something or do you not see something? If something is there and you see it, that's a hit. If something is not there and you say it's not there, that's a correct rejection. So in this case, if you were to say, yep, there it is, 10 stars in a row right there, and you said present, you would be correct. That's an example of a hit. For the 400 star field, we have this example right here. And if you said that, there's no target in this star field, target is there. If you said that there's no target, that's a miss. That would count as a miss. If you said there is a target, target's right there, and you would be correct. And then just so that you recall what 1,000 star field looked like, that's it right there. And I'm going to cheat a little bit and just look. So, right. No, this one is actually absent. All right, so there is no showing you the challenge of the 1,000 star field. There is no target in this one. So if you said, yes, it's present, that would be a false alarm because you're saying, yes, there's something, but there's no signal present. If you said, no, it's absent, that would be a correct rejection. So this entire experiment was set up to see how often are you going to get hits, how often are you going to get misses, how often are you going to get false alarms, how often are you going to get correct rejections to measure your sensitivity. All right, so the 144 star field results. So these are the results in terms of the hits and false alarms and correct rejections and misses. And you'll notice that the hits and the misses, those are when the signal is actually present. So they are going to add up to 100, right? We got 0.94 and we got 0.06. They're going to add up to 1, meaning 100% of the time, if there is a target present, you're either going to get a hit or a miss, right? Because those are the only two options. 100% of the time, if a target is not present, you're going to get a false alarm or a correct rejection, and that's why these add up to 100% as well. So the way that signal detection would use this is they would say, all right, let's take a look at the star field plus the target, the noise plus the signal. And in this case, we have 94% of that distribution is hits. 94%. When the star field, when the target was there, 94% of the time we said, yes, I can see it. 6% of the time, we had misses. So what that means is that our criterion has to be right there. So our criterion is such that it splits up the hits and the misses into that 94% and 6%. Now, that's where the criterion is. What we now need to do is we need to fit a noise distribution so that 23% of the noise distribution is on this side of the criterion, so we got 23 false alarms, and 77% of the noise distribution is on this side, so we got 77% correct projections. The only place we can do that is right there. That puts 23% on this side, 77% on that side, and that locks these into position with which we can measure the sensitivity. And as it turns out, you have a sensitivity of 2.85. Now, the units of this sensitivity don't really mean anything, but it's a way of comparing how sensitive you are in different situations in the same experiment. So remember that number, 2.85. That was your sensitivity. That's how good you were at detecting those 10 stars in a 144 star noise distribution. All right, 400 star field results. What happened here? Well, here, not so good, not as good. So our hits went down. It used to be 94%. Now our hits went down to 70%. Misses up to 30%. So now we missed the target 30% of the time. False alarms also increased, went up from 23% to 39%. Correct projections had to go down from 77 to 61. So once again, we can do that analysis where we fit the signal, the star field plus target distribution, the signal plus noise distribution, so that we got 70% hits and we got 30% misses. That puts our criterion in a single location, and then we have to fit the noise distribution so that 39% of it is on this side of the criterion, so the false alarms, 61% of it is on this side. Only place we can do that is to put it right there. We can then measure the distance between the two peaks, and you can see that our sensitivity went down. When we had more distractors, when we had more stars to look at, it was harder to locate those 10 stars. Our sensitivity to those 10 stars went down. It used to be 2.8 something. Now it's just under a sensitivity of 1. And as you can imagine, this trend continued for that should be 1,000 star field results. So for the 1,000 stars, once again, we have our analysis. This time we got 61% hits, 39% misses, and look when it was absent. We were just about chance. Half of the time you thought you saw 10 stars, but you didn't. Half of the time you correctly said, nope, there aren't 10 stars there. So once again, we fit our graphs. We need 61% hits when the star field and the target were both there. So that's 61% for hits. Now we have 39% for misses. That fixes our criterion in a specific location. And now we have to put our noise distribution so that 51% of it is above the criterion, 49% of it is below. That's the only place that it can be done. That's your sensitivity right there. So your sensitivity went down to 0.29 in the 1,000 star field. So it doesn't matter if you were really trying to err on the side of seeing the target. If you were trying to err on the side of not seeing the target, your sensitivity could be measured by signal detection, and not surprisingly, it's much lower in the 1,000 star field. All right, so any questions on that analysis or signal detection theory in general? All right. So, did your sensitivity to the target change as the star field increased from 144 to 400 to 1,000 dots? The answer to that, as we just saw, was yes. So sensitivity for the 10 star target in 144 distractors was 2.89. Sensitivity in 400 distractors was 0.99. Sensitivity in 1,000 distractors was 0.29. Those numbers went down, indicating that your sensitivity went down. Your ability to detect that target went down. So let me ask you this. This is more of a kind of introspective question. Did anybody move their criteria as the star field changed from 144 to 400 to 1,000? Another way to answer that is, did anybody guess more towards, yes, the stars are there, or did you guess less towards, yes, the stars are there as it went? So anyone want to share their experience? Mm-hmm.
I know I had a couple, I guess, false alarms because I would think real quick that it was a straighter pattern, and it ended up not being. And then after it told me that, when I kind of saw it again, I was like, oh, maybe I kind of looked too fast, like the more stars that there were.
So did you take more time looking later on after you got that feedback?
Yeah, after I saw it, I was like, oh, okay, that wasn't exactly what they were looking for.
Mm-hmm. Same thing? Yeah. Anybody else have a different experience? Maybe got more conservative as the stars increased? Okay, so many of you probably had that same experience. That tends to be a lot of times what happens when people get into that 1,000 star field. You tend to kind of slow down, you tend to make more mistakes, so you're a little bit more cautious. The key thing in this signal detection paradigm and why it's so powerful is that that doesn't matter. The fact that you changed your strategy does not make you better at, or does not increase your sensitivity. Your strategy will have no effect on the final sensitivity measure. Because if you start taking your time and you're more conservative about trying to find the star field, what's going to happen is you're going to increase your hits. You're going to increase the times that you do see them, but you will also increase your false alarms. One goes hand in hand with the other. If you start reacting more quickly, you're going to increase your misses because you're not going to see the star field, the targets as much, but you'll also increase your correct rejection. So that's the power of signal detection. It doesn't matter whether you're trying to be exact or you're not trying to be exact. It doesn't really matter if you're trying to, err on the side of caution or err on the side of being more aggressive. It will still measure your sensitivity in this particular situation. All right, and that is kind of what I answered right there. So why is it so important? It's so important because it's a criterion-free way of measuring sensitivity. It's a bias-free way of measuring sensitivity. It really gets past all the sort of psychological things that people might do to try to change their answers, and really gets to the heart of what can your mind, what can your perceptual system really tell the difference between. All right, and how does this apply to perception and cognition? So did anybody think about times in their life over the past weekend when you made a yes/no decision and you kind of identified what would be a correct hit, what would be a correct rejection, what would be a hit? Anyone? Yep.
Yeah, so I was at a wedding on Saturday, and it was like super loud, and like one of my friends from high school was behind me, and we were talking previously, and I could have swore that she like said my name. And I turned around and I was like, did you say something? So that was like a false alarm.
Yeah, that would exactly be a false alarm. And if she did say your name and you ignored her, that would have been a miss. And if you ignored her and she didn't say anything, that would be a correct rejection. And if what you did was the hit, I think that was all four, right? You might have missed one of them. But anybody else have an example that came up? So that's a nice example of a very kind of like perceptual aspect of this. But this can also apply to higher levels of cognition. So for example, let's stay with that example of a wedding. Maybe not for that wedding. I'm sure they're going to be happy forever. But oftentimes when people go to weddings, they will kind of take a look at the couple and they'll try to make a decision. Is this going to last or is this not going to last? And that is a signal detection paradigm. So you're looking at the couple, you're looking at how they interact, you're taking the evidence from their dating history, you're taking the evidence from their personalities, you're putting all that evidence together, and you're making a yes/no decision. And if you say, yep, they're going to stay together forever, and they do stay together forever, that's a hit. If you say they're going to stay together forever, and then they separate later on, that's a miss. If you say that they were going to separate later on and they don't get married, that's a correct rejection. If you say that they're going to get together and they don't get married, that would be an example of a miss. So it can be applied to very high order types of cognition. And that's what we're going to turn to right now as a sort of final go-away synopsis of why we do signal detection. Because when you're looking at stars in a star field, sometimes, especially in cognitive psychology, it's easy to miss the big picture and the big application. So anytime that you kind of look at anything in cognitive psychology, always sort of challenge yourself to think, well, how could this be applied to the real world? How could this be applied to real world issues? Because, finding a line of 10 stars in a star field is not important, right? I mean, it's an important experiment, but let's not kid ourselves. Nobody's life is going to make it or break it on whether or not they can find 10 stars in a star field. However, signal detection theory can help us understand and make predictions and make suggestions on very important topics. And one of the ones that is important these days is the Me Too movement. So the idea of sexual harassment, sexual assault, the entire sort of impetus of the Me Too movement. I think Weinstein, his defense attorneys, I think, started on Thursday. I think the prosecution rested, but now the defense attorneys are starting. So this can be applied to a signal detection paradigm can be applied to understanding sexual harassment. So we're not going to talk about the legal cases. So Kevin Spacey and Harvey Weinstein, both of those, if allegedly, for the YouTube audience, allegedly are being accused of passing the legal criterion for on this side it's sexual assault, on this side it's not sexual assault. So that's a legal thing, and we don't need to delve into signal detection to sort of take a look at that as much. But let's take a look at something a little bit more in the gray area, which is sexual harassment. So not assault, not illegal, but harassment, the type of harassment that you might encounter in a workplace, the type of harassment that you might encounter on a date, the type of harassment that the internet was split on when they were asking whether Aziz Ansari did anything wrong in his date with a photographer, I believe she was, and half of the people were like, yes, he sexually harassed her. Half of the people were like, no, he did not. And that indicates that people are trying to do this signal detection. Was it harassment? Was it not? Did you correctly identify it or did you not? So signal detection theory can be applied to something as high level as this idea of sexual harassment. So let's take a look at that to round out our look at signal detection theory. So signal detection theory, we start with a noise distribution. In sexual harassment, in sexual relations, your noise distribution is basically what is going on in somebody's mind when the other person does not want sex. So this evidence is happening in one person's mind. And this is what the other person is trying to communicate, right? So, I do not want sex means that there is no evidence being given from the partner that they wish to engage in any sort of sexual situation, whether it be, any sort of sexual situation, right? So that's the noise distribution. And then this is the signal plus noise distribution. This is what the person does when they actually do want sex. And you can see that this is kind of ingrained in our society because oftentimes when people say, well, why did you do that particular behavior? Why did you initiate, or try to initiate a sexual relation? And they'll say things like, well, the other person, they were giving off all the signals. They were putting out all the signals. I was just reading the signals, AKA, they were giving off evidence. So what do we do here we have one situation where the person does not want sex. You have one situation where the person does want sex. And what we do as human beings is we choose a criterion. We choose a criterion, and above that criterion, we will engage in sexual relations. Above that criterion, we will say, you know what? Oh, and the other assumption here is that the person whose mind we're looking at does want to initiate sexual relations. All right, so they've already made the decision that they would like to engage in some sexual relations, and then they're trying to read what the other person is intending. I do want sex or I do not want sex. That's the criterion that they might set. And notice, in this case, we can use signal detection to determine, number one, what is their sensitivity, but also what are the outcomes of this encounter. So let's start off with the person does want sex. So they do want you to engage. They do want you to initiate a sexual encounter. If their evidence falls above criterion, well, that's called a hit. So they would like you to initiate a sexual encounter. You want to initiate a sexual encounter. You decide that there is enough evidence that you will proceed, and that's called a hit. And everybody walks away happy in the morning. On the other hand, though, if the person does want to engage in a sexual encounter, but the evidence does not pass criterion, well, then that's called a miss. And that's when somebody is, probably a lot of people have had this experience where somebody's flirting with somebody and it's obvious to everybody except the person is being flirted with, and the person just leaves, and the other person is like, what just happened? Well, not enough evidence. It was a miss. It fell below criterion. So if it's a hit, you get sexual activity. If it's a miss, then it's a missed opportunity, right? And maybe you realize on the drive home, you're like, oh no, what did I do? Anyways, that's what happens when your potential partner wants to engage in sexual activity. Also, out of the corner of my eye, I can see kind of the squirming in the seats. This is what we need to do as psychologists. We need to delve into some of these issues. So I'm just going to blaze ahead here. And we'll just keep going. All right. The other side, the person that you're with, the person that you're talking to, the person that you're having this social interaction with, they do not want sex. That's the other possibility. In that case, once again, you have your criterion. And if you decide, this person does not want sex, I would love to have sex with them. This person does not want sex, so we're not going to do anything. That's a correct rejection. If, on the other hand, you decide that they do want to have an encounter and you start pursuing that, that's a false alarm. Correct rejection, everyone walks away okay, right? You're like, well, maybe next time, and they're like, well, I'm feeling good. Everybody walks away okay. False alarm, that's sexual assault. So if you go the full-on, if you do the full-on sexual encounter, that would be sexual assault. So that is the sort of 4 possibilities in this signal detection paradigm. And one of the things that we have noticed so far, or one of the things that is apparent in signal detection, is that this sensitivity here, it's very difficult to increase without a lot of practice. So you probably did not get very much better at locating that target as you continued on in your experiment. So this sensitivity is difficult to increase. But look at all this red over here. We don't want that. Especially we don't want this, right? This is the worst outcome. This is the bad outcome. This is what we're trying to avoid. This one over here is livable, right? Sure, it's a missed opportunity. There'll be other chances, but nobody gets hurt. Nobody's violated. Everybody's still fine. This one, have a good time. This one, your choice. This is what we want to avoid. And in signal detection analysis, you can figure out how to avoid this. It would be nice if we can increase the distance between this. It would be nice if we can make people more sensitive to these signals. It would be nice, that's the goal of a lot of sensitivity training. Again, it's in the name. They're trying to increase your sensitivity to certain situations. That is very difficult to do. Easier thing to do that would still get rid of this is to move your criterion. And that's what policies, like Indiana University's consent policy, is trying to do. So their consent policy is consent is an agreement expressed through affirmative, voluntary words or actions. So literally what they're saying is, this is the amount of evidence that you need in order to say that a sexual encounter is wanted. This is a lot of evidence. So what they're saying is that this is where your old criterion used to be, right, with previous types of consent, with the sort of, well, you know, they were putting off all the signals, I kind of got the feeling that they were into it. That's the old type of consent with that criterion. And that led to this problem. If you have this type of consent, what it's saying is, that's your old criterion, we need a new criterion, we need that criterion way over there. We need a lot of evidence way over here. And notice what this does is it gets rid entirely of that sexual assault. However, now you'll notice that we have massive amounts of missed opportunity. So this is better than this, right? We definitely don't want sexual assault, but we also don't want a ton of missed opportunities. So what else needs to be done? Well, the other thing that we can do, we can't increase sensitivity, but we can increase evidence. We can increase the signal. And that is one of the reasons I believe that concurrent with the whole Me Too movement, the idea of playing hard to get is just falling out of favor in our society. So when I was looking up for articles to illustrate this point on playing hard to get, I kind of proved my own point. The last one I could find in a major publication was in 2012, right? So 8 years ago was the last time any magazine was kind of saying, well, here's how you can play hard to get. Here's some of the techniques that you can do. And playing hard to get, it works psychologically. So that's why it's been used before, but it's not good. It's not a good thing for these missed opportunities. So playing hard to get literally says, when you send out your signal, don't send out a lot of signal, right? Act a little bit coy, act a little bit reserved, play a little hard to get. And if we do that with the new type of consent criterion over here, massive missed opportunities. And that's what a lot of people always criticize these sort of policies on. However, if we start to agree that it is completely fine to give evidence that you do want to engage in sexual activity, what's going to happen is that this amount of evidence is going to increase, and we'll get away all the way over there. And then notice we'll still have some missed opportunities, but importantly, a lot of hits, a lot of correct rejections, no false alarms, which is the sexual assault, and this is a better situation all around. So we move the criterion, we get rid of hard to get, and that takes us from this situation into a more safer and beneficial situation for all involved. All right, any questions on that particular analysis? All right, so we're going to do one more of these, just because I don't think the level of uncomfort in this room is high enough right now, so we're going to ramp it up a little bit more. So this was sexual assault. We also mentioned about sexual harassment. That's also an issue these days with whether or not, how to engage in the workplace. What sort of things can you say in the workplace? What sort of conversations can you have? What's considered sexual harassment, what isn't? So once again, we have this idea that sometimes, again, if you are looking at a person, so if this is in your mind, and you look at a person and you think to themselves, you know what, that person wants some we're going to call it sexual attention, right? Another way to say that, they want a compliment. They want somebody to say, you know what, you're looking particularly good today. You know what, those jeans look amazing on you. You know what, that sweater really brings out your curves, right? That's a nice compliment to get if you want that compliment, right? If you've been hitting the gym, if you've been good since January 1st, it's nice to hear that, oh yeah, it's really paying off. You're really looking good in those jeans. So sometimes people do want the compliment, right? And if you give somebody a compliment when they do want the compliment, well, that's welcome sexual attention. If you don't give the compliment, that's a missed opportunity. And they, that's not too bad. They walk around going, well, what am I going to have to do to get some attention around here? But that's not a bad thing. If they do not want sexual attention, right? If they're just dressing for themselves and they don't need any, validation from the world or anything like that, and you decide that their evidence is below criterion and you don't say anything, everybody walks away okay. What happens though is, once again, these false alarms. That's the bad area. These are the people that are at work, that are constantly being hit on, constantly being told comments about their body, do not want it, just want to do their job, and are being harassed. And that's the issue that people are trying to get rid of. So one thing that I came across, which was really interesting when I was doing research on this, was called for sexual harassment in the workplace. It was called the Rock test. And does anybody know what the Rock test is? All right, so this is more aimed at males who might be harassing female coworkers, but the Rock test was suggested by, I can't remember who suggested it, but Dwayne Johnson actually endorsed it. And what it is it's a test that basically says if you're going to give somebody at work a compliment, ask yourself, if you are working with The Rock, would you tell him? So if you see somebody and their jeans just look amazing, and you just have this feeling that, you know what, I really want to give them that compliment. I want to tell them that their jeans look amazing. Take a second, ask yourself, if that was The Rock, would I feel comfortable and make the same decision and say, Mr. Johnson, your jeans look amazing, right? If so, go ahead and do it. If not, pull back. That was the sort of advice. And what that does is, once again, it doesn't change your sensitivity, right? Because it's hard in social situations to know, do they want to compliment, do they not want to compliment? Is it rude to say something? Is it rude not to say something, right? We're all, usually trying to do the right thing to get along. But it's that sensitivity. It's hard to know where you are. So what the Rock test does is it takes this criterion and it says, this is for a normal person. This is where you would set the criterion for a regular individual. That's where you set the criterion for The Rock. You better be sure that he wants to hear about how good he looks in his jeans before you say, you look really good in your jeans. And notice what occurred. All of the sexual harassment, gone. Welcome sexual attention, still there. You can still say the odd occasional compliment when you're sure, when you have a lot of evidence. A lot of missed opportunities, but that is what needs to be done in order to get rid of that aspect right there. All right, so any final questions, comments about this application of signal detection theory? All right, cool enough. So what we're going to do now, we got about half an hour left. We're going to we're finished with signal detection, and we're going to now intro ecological psychology. So we're not going to get through the whole thing today, but we'll at least get the basic premise, we'll get the basic ideas down, and then complete it on Thursday. So we're a little bit behind in the syllabus, but we should be able to catch up over the course of the next couple of classes. All right. So we're going to take a look at perception, once again, from an ecological psychology standpoint. We're going to talk a lot about some fundamental ideas of ecological psychology, including texture, including the ambient optic array, perspective structure, a key idea, invariant structure. We're going to talk about affordances, which is one of the most, sounds silly, but is actually super helpful. And that's going to be our look at ecological psychology. So ecological psychology was developed by James Jerome Gibson. And I mentioned that this is near and dear to my heart. and I mentioned that I'm kind of from this lineage. So when I did my PhD, my supervisor was Dr. John M. Kennedy at the University of Toronto, and when he did his PhD, his supervisor was J.J. Gibson. So I'm kind of, he's like my grand supervisor, right? We come from the same, lineage. So ecological psychology was this paradigm that he came up with. And one of the most amazing things about Gibson, and one of the most amazing things about my supervisor, Dr. Kennedy, and something that you should take with you when you do psychology, is that he was very, very comfortable and okay with saying that he was wrong and just trying something else. So he didn't hold on to his ideas. He didn't hold on and guard his kind of accomplishments. If a theory that he had been working on for years just was not working and he decided it's not the right theory, he would just abandon it and say, let's start from scratch. And that's how he came up with ecological psychology. So if you do get into Gibson's work, one of the kind of things you need to do when you get into Gibson's work is you need to pay attention to the year of the publication. Because Gibson 1957 is a very, very different Gibson than 1971. It's a very, very different Gibson than Gibson 1960s. So that was one of his massive strengths. If something wasn't working, just throw it out the door and start fresh. And one of those fresh starts was ecological psychology. So the starting point for this is the idea that perception is not about internal experiences. It's not about you having this internal experience in your mind of the external world. What the goal of perception is to guide action. The reason we can perceive the outside world is that it guides our action, it guides our ability to adapt and interact with the world. So it's not about these mental inferences, it's not about these internal experiences caused by sensations. It's about adaptive moving through and acting with the world. So this idea of action was very new, was very different. You'll notice, if you remember back from our textbook definition of perception, that it's a experience from a stimulation of the senses. Notice that is this definition down here. Ecological psychology came at it from a completely different area and came up with massive, huge insights because of that. All right, so in ecological psychology, perception is direct rather than, it's direct, which means that you pick up information directly from the environment. It's non-inferential, meaning that it is mostly bottom-up. It is not top-down. You don't have to have hypotheses. You don't have to have a lot of higher order processing from the top coming down to interpret your signals. It's mostly there in the environment. Information is gathered from your environment. So this was the beginning of his view of perception. So one of the reasons why this approach was needed has to do with the sort of history of psychology as a science. And one of the things that happened was psychology as a science came about kind of late in the game. So you'll learn about this in history and systems. And for the longest time, people thought the mind just couldn't be studied, right? It was just beyond the realm of possibilities. And then eventually they were like, well, no, look, we have these techniques that we can do to study the mind. By that time, other sciences had already been established. So physics had been established, chemistry had been established, biology had been established, and they had ideas and concepts and techniques that they used that sort of made them a science, right? They could say, well, I'm a physicist, and physics is science because we do these scientific things. So what psychology did in order to be taken seriously as a science was to say, well, the things you do, physics, we also do those things. We use the same concepts and the same ideas. We're science too. Like us, please. So that was just our coming of age story. And because of that, a lot of people working in perception, in psychology, said, well, what is physics doing? Let's take those ideas and we'll just apply them to the mind. It worked for physics. They're a great science. We want to be a great science, let's do the same thing. So there was a widely accepted framework in physics that what you have is you have bodies in space. So if you're trying to analyze motion, if you're trying to analyze the planets and how they orbit, you have bodies and they exist in space. So this cup here is a body, this area here is space. That's what physics, concepts that physics had. What we perceive according to the physics approach is objects in space. So we perceive the objects that are located in space. And the best way to approach this is an abstract mathematical approach, right? So physics is very well served by abstract mathematical formulas. So something like, very famous E equals mc squared, right? That's a math formula. And that fits the relationship between energy, mass, and the speed of light very, very well. It's a great way to understand physics. It's a great way to understand the universe. As it turns out, it doesn't work for psychology. And then the last one was that it was very passive. So physics by itself is very passive, right? Physics doesn't need an active agent in order for physics to occur, right? There's nobody that needs to do things in physics. The planets orbit because of gravity. Everything's gravity. Things fall because of gravity, right? Surfaces have hardness because of molecular bonds. There's nobody there doing something in physics. It's just the universe operates the way that it does. That's very passive. So what the ecological framework came in with was it said, all right, we're going to not use this framework. This is a physics framework. And they took it from physics, and it doesn't work for psychology. This is an example of Gibson saying, we've been butting our heads against this problem for too long. Let's throw it out. Let's start fresh. So he came up with the ecological framework. And instead of bodies in space, what he came up with was mediums, substances, and surfaces. So a substance is anything that has stuff to it. So this is a substance. A medium is anything you can move through. So the air here is a medium. Water is a medium. And a surface is anywhere where a medium meets a substance, or a substance meets another substance. So that was his kind of beginning idea. It's a very subtle change from bodies in space, but as we're going to see, it's very important. What we perceive as objects in space, Gibson said, no. What we perceive are surfaces in a medium. We perceive the surface of this table. We don't perceive the inside of this table. We perceive the surface, and only the surface. Abstract mathematical approach, Gibson said, no, we're going to take an approach that is based on an organism in an environment. And this was one of the big, really important moves, because perception cannot occur without an organism in an environment. You need an environment, you need an organism in that environment. Those two are linked, and that was missing in physics. And once you have an organism in an environment, once you have a doing thing in a place where you can do things, then all of a sudden perception is no longer passive, it's actually active. There's an active component to perception that ecological psychology used to answer a lot of these very, very difficult questions. All right, so medium, substances, and surfaces. What are we talking about when we're looking at substances? What are we talking about when we're looking at organisms in an environment? One of the first things that this brought about was the important idea of texture. Texture is vitally important to understanding how we perceive. And the reason for that is because everything has texture. So let's take a look at what happens when you don't have texture. Let's say that I have this window here. And outside of this window is some sort of structure. And that's what you can see through the window. Notice that this is an idealized physics framework type of object, right? It's a uniform object. It's a type of object that you could describe very easily with a mathematical formula. What could this thing possibly be? Well, if we take a look at somebody looking through that window, so this is from the top, there's the window right there. What are we looking at here Well, it could be a wall that's oriented like that, right? It could be this wall that this individual is seeing through their window. That's the orientation parallel to the window. So far, so good? All right. The challenge with using the physics framework is that it could also be that wall right there. So it could be that this is what the individual is seeing. This part of the wall is very close to the window. This part of the wall is very far away from the window. But it's a uniform wall. It's a uniform texture. It's a simplified physics texture. There's no way to tell if it's that wall, or this wall, or if it's this wall over here. There's just not enough information in this stimulus. So because of that, and you'll remember this from our intro to perception, because of that, top-down processes are required. You cannot answer what wall is this without some top-down processes, without saying things like, well, in our cities, usually things are parallel. Usually buildings are built on a grid form, so you would take that knowledge and decide that this is the wall that you're looking at and not this wall and not this wall. But importantly, top-down processing was absolutely required. You had to infer something about that wall through that window. That's for that wall over there. There's not a single wall in our world that looks like that. There's not an idealized wall out there that looks like this physics framework wall. What do our walls look like? Our walls look like this, and they have texture. So these little units over here of these bricks, those are texture. And texture immediately, in this case, tells you you're looking at a parallel wall. You don't have to do inferences. You don't have to do guesswork. You don't have to know anything about how cities are built. This orientation here, this form of texture, immediately tells you that you are looking at a parallel wall. And this becomes evident when you go away from physics and you go into Gibson's ecological psychology. Because as it turns out, texture is very important because everything in our world has texture. So the bark of a tree has texture. The towel that you use to dry your hands has texture. Tiles on the floor have texture. A tablecloth has texture. The tiles in here, they have texture. This cup has texture. My shirt has texture. Your clothes has texture. These walls have texture. I can basically just keep randomly pointing at things. Everything has texture. That's what the real world is. Not the physics simplification. That's what the real world is. And we have even just, if you're looking at stones on the ground, they have a texture and they follow certain rules. So while these stones are all differently sized, on average, these stones over here are about as big as these stones over here. And that information is stuff that your mind can use to perceive the world at large. So another example, sunflowers in a field, that's texture. And notice that this is just something that happens over and over again in nature. This is just the way that our world is built. And when we look out at this, notice that down here, in this area of our visual field, the stimulation that's coming to this area, notice that we have like 1, 2, 3, 4, 4.5. We got 4.5 sunflowers in that little area. Up here, we got what, 20 maybe sunflowers in the same area. So up here there's 20 sunflowers, down here there's only 4. That tells our mind immediately, directly, that these sunflowers are further away. Because in the same area, there's many small units of texture. Down here, fewer large units of texture. That tells us immediately these flowers are far away. These flowers are very close. That's the real world. You go back to physics, that information is gone. Right? All of a sudden, you don't know. Is this close? Is this close? Which one is close? Which one is far away? It all revolves around the idea of texture. So we are going to continue with our look at ecological psychology and going into the ambient optic array next class because I do want to kind of hit that all together. But just as a sort of conclusion, again, the big move was taking a look at the physics framework that was going nowhere, saying throw that out. Let's take a look at what is really going on in the environment, organism in the environment, try to use features that are really out there in the real world, and that was the basis of ecological psychology. Are there any questions on that kind of intro before we wrap it up for today? All right, so that is it for today. So next class, we'll pick it up here. We'll start off with the ambient optic array. But other than that, we are done for today.